Let's dive into one of the most mind-bending ideas in all of physics. It's a concept so strange, so counterintuitive, that it literally keeps one of the world's most famous astrophysicists, Neil deGrasse Tyson, awake at night.
I mean, that's a pretty intense way to kick things off, right? But this isn't just some abstract thought experiment. It's a fundamental truth about our universe. And honestly, it messes with everything we think we know about reality. And yeah, by the end of this, you might be staring at the ceiling tonight too.
Just think about that question for a second. We all kind of walk around assuming that time is this constant thing. You know, a universal clock ticking away for everyone, everywhere, at the exact same rate. But what if that's just not true? What if your clock and my clock could actually fall out of sync? So how is this even possible? Well, to get our heads around it, we need to look at two fundamental rules of the universe, both figured out by the one and only Albert Einstein. These aren't just ideas. They're the rules that govern how the very fabric of space-time and time itself can be stretched, bent, and warped.
It really just boils down to two things. First up, speed. Einstein's theory of special relativity showed us that the faster you zip through space, the slower your personal clock ticks compared to someone who's just standing still. And second, gravity. His other big idea, general relativity, revealed that gravity does the same thing. The closer you are to a really massive object, like a planet or a star, the slower time flows for you.
And here's the absolute kicker. This is not science fiction. It's not a what-if or some wild hypothesis. This is a proven, measurable fact of our reality. It's woven into the cosmos, and you've almost certainly used it today without even knowing it.
Okay, so where's the proof? Well, it's not hiding in some dusty old textbook. It's all around us. We're going to look at two incredible examples. One that's probably in your pocket right now, and another from the super weird world of particle physics.
Seriously, believe it or not, that little map on your phone that gets you from A to B is a constant real-world demonstration of relativity in action. Without Einstein's formulas, your GPS would be completely useless within minutes.
So here's how it works. GPS satellites are way up there, orbiting high above the Earth, where gravity is a little bit weaker. According to general relativity, this means their clocks literally tick faster than our clocks down here on the ground. Now, the difference is tiny. We're talking nanoseconds, but it adds up. If we didn't correct for it, your GPS would be off by several miles every single day. So the engineers actually built Einstein's equations right into the system to constantly adjust the time. It's amazing.
You can just imagine the moment the engineers turned the system on and checked the data. It wasn't just elegant math on a blackboard anymore. It perfectly predicted a real, measurable effect out in the world. The system worked. Oh my gosh, Einstein was right.
Okay, so GPS has the gravity part covered. But what about speed? Well, for that, we have to go from the vastness of outer space down to the tiniest subatomic level, where we find some of the most powerful proof there is.
And this proof comes from a tiny particle called a muon. Now, a muon is really unstable, but the key thing you need to know is that it has a super precise, predictable lifespan. Think of it like it has a tiny internal wristwatch that's perfectly wound and tells it exactly when to decay. It's the perfect little clock for our experiment.
Now get this. When a muon is just sitting still, its little internal wristwatch runs out in about 2/millionths of a second. Poof, it's gone. But when scientists take those same muons and accelerate them to 99.9% of the speed of light, something incredible happens. Their personal time slows down so much that they last almost 30 times longer. And here's the best part. It's not just some random number. It's the exact amount predicted by Einstein's theory of special relativity.
Okay, so we've seen the rules in action. The faster you go, the slower time gets for you. So let's take this whole idea and push it all the way to its absolute, logical, and most mind-shattering extreme.
What happens when you push the pedal all the way to the floor? Not 99%, not 99.999%, but what happens if you could hit the full cosmic speed limit? This is the question that really gets to the heart of what keeps Neil deGrasse Tyson up at night. The answer is, time stops. It just ceases to exist. For a photon, a particle of light traveling at light speed, there is no such thing as time. Its clock doesn't just slow down, it comes to a complete and total halt. To really let that sink in, imagine a photon that's born at a star 30,000 light-years away. Now, from our perspective here on Earth, that little particle of light has been on an epic journey, right? It's been traveling for 30,000 years across the cosmos before it finally ends its trip in one of our telescopes.
But from the photon's point of view, for the photon itself, how much time passed on its own clock during that incredible 30,000-year trip? Zero. Zilch. Not a second, not a nanosecond, nothing. The entire journey was instantaneous. And this right here brings us to the final profound revelation. This isn't just a quirky physics fact. It's a peek behind the curtain into the true, utterly bizarre nature of our universe, where time itself is not the fundamental constant we all thought it was.
This is the key. For that particle of light, there was no journey. The moment it was created at that distant star is the exact same instant it was detected by our telescope here on Earth. Its 30,000-year trip through space happened in zero time. From its perspective, the beginning and the end are the same moment. And that is a thought that might just keep you staring at the ceiling tonight.